Hi, in this video, I want to talk a little bit about the difference between layer 2 and layer 3 redundancy, just a little bit more than I talked about previously. So layer 2 redundancy, again, the reason why we use spanning tree to actually block a port is, as I mentioned before, layer 2 switches, Ethernet switches, are going to flood out unknown unicast. Those are Ethernet frames where the destination MAC address is not in the MAC address table. It will flood it out all ports, along with flooding out broadcasts. And we saw the danger of doing that previously in previous videos, where without spanning tree, if we didn't block the loop, keep loops from happening, it would bring down our network faster than we can say spanning tree. Spanning tree is a great protocol for solving this problem. However, in doing so, as you can probably see, it reduces the number of links that we can have. We can't load balance between Ethernet switches like this. It also, in complex topologies, our spanning tree topology can be quite complex. And there can be issues when you have bad links or bad ports or whatever. It can be problems with slow convergence. Or even when a link goes down, convergence can sometimes be an issue, can take a little bit of time. Rapid spanning tree has actually done some things to help solve that. But the main part is spanning tree topologies can be quite complex, trying to figure out what is the paths that your frames are taking, where you should be placing the root bridge or root bridges for different VLANs, and you're going to have blocked links. So there has been a move to kind of move away, from layer 2. Layer 2, we always kind of think of as the good thing is that, switches are fast. This is all done in hardware. And we used to think, well, not used to think, it used to happen. Routing happened in software and was much slower. So we try and switch where we could and route wherever we had to. But things have kind of changed now with routing, or have changed, that a lot of routing is being performed in hardware. And we can look at things like Cisco Express forwarding, if you know a little bit about that. If not, I'd talk about it in other classes or in other videos. But a lot of the routing also happens in hardware, and we can get the same type of wire speed advantages we find in switching. We can now see those in routing as well. So the benefit of routing is that routers can actually take multiple paths. There are no blocked links here. The thing is that in layer 2, where everything was one IP network in our layer 2 domain, here everything is a different network. So each one of these interfaces or these links is a different IP network. And to be honest with you, with IPv6, this makes it a lot easier. We have a lot more subnets that we can use, and it's a lot easier to subnet in IPv6 than it is IPv4. So we don't have to have any blocked links. All these links are usable. We can even do load balancing. We can use multiple paths. If a link happens to go down, then the dynamic routing protocol is used to converge and update the individual routing tables to the new best paths. So there's a move to kind of get away from this layer 2 links everywhere and using same IP network to moving more towards routing everywhere. There are situations and places now where people are actually getting rid of layer 2 switches and going layer 3 everywhere. And just makes everything a lot easier to manage your traffic flow. All the links are available. We don't have to worry about spanning tree convergence. We know exactly what our paths are. We can have multiple paths, load balance, etc. And again, IPv6 makes this a whole lot easier. All right. So anyway, I just wanted to throw that out there, and look forward to talking to you in more videos on Spanning Tree.